Welcome. More on probability. We'll be looking at dependent events. When are events more than one event? When are they dependent? That's when the outcome of one event has an effect on the possible outcomes of the other event. Say we have a bag, it's not a see-through bag, a bag of marbles again. Let's say we're going to pick out a marble without looking twice in a row. We don't put the marble that we pick out back in the bag after we've looked at its color, but we pick it out and we leave it out. The chances of randomly picking a blue one are 2 out of 5 at the start, right? 2 of the 5 marbles are blue. So chances of 2 out of 5 to pick out a blue one. Say the first one is blue. And I go to pick out my second marble without looking inside the bag. What are my chances of getting a blue one now? Well, the chances are different. They're now 1 out of 4. So the chances are different because I already picked out a first one. And because it was blue, my chances are now 1 out of 4. If I'd first picked out a red one, my chances of getting blue on the second draw would be 2 out of 4. So greater. So if we're picking marbles out of a bag twice in a row, and we don't put the marble that we pick out on the first go, if we don't put it back, then the contents of the bag are different. So the chances of getting either blue or red are different on the second draw than they were on the first draw, right? That makes sense logically. Let's look at what kind of effect that has on our probability tree. We're picking a marble out twice. So first draw, we could get red or blue. Yes? After we pick out red, on our second draw, we can get red or blue. After we've picked out blue, we can, again, pick red or blue, right? The possible outcomes here, red, 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 red. Here would be red, blue. Let's write blue with blue. Blue, red. And blue, blue. Those are the possible outcomes, right? Now to calculate their probabilities, we need to write the separate probabilities on the branches of this tree. So at the start, the bag is like this, right? So chances of getting red on the first draw are 3 out of 5. 3 out of 5. Chances of getting blue on the first draw are 2 out of 5. 2 out of 5. And these add up to 1, so we're good. Now here on our second draw, if it follows the event of getting a red one first, we have to imagine the red one that we picked out on the first draw is already out of the bag. Yes? So then following that event, what are our chances of picking red again? Let's look at the bag and what it looks like now. There's 2 red ones out of a total of 4. So 2 out of 4 getting red again. What are the chances of getting blue after we picked out the red one and left it outside of the bag? Chances of getting blue now are 2 out of 4. Again, these add up to 1. What if on our first draw we'd picked out blue and left it out of the bag, right? This is the first event. It's already happened. Imagine it outside of the bag. What are our chances now of getting red on the second draw? It's 3 out of 4. 3 out of 4. What are our chances of getting another blue one? Let's look at the bag. There's only 1 blue one left out of 4. So 1 out of 4. These two add up to 1 again. So we're good. Okay. And then those lead to the end outcome of our two events, red, 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 blue, blue, red, or blue, blue. And let's calculate their probabilities. We multiply across the branches. So the chances of getting red and then red are 3/5 times 2/4. And that is 3, am I right? 3/10? Yes. Chances of getting red and then blue, 3/5 times 2/4. I'm just going to write 1/2, right? That's easier to visualize. 3/10, once again. Chance of getting blue then red, blue was 2/5 times then red 3/4. That would be 2 times 3 is 6. 5 times 4 is 20. Ooh, we can simplify this to 3/10. Getting blue on the first draw is 2/5, just like here, times 1/4. The chances of getting, that's this last one, chance of getting blue on the second draw after you've already picked out a blue are small, right? Or small. 1/4. 2 times 1 is 2. 5 times 4 is 20. And we can simplify this to 1/10. Now let's just check to see whether we did all these multiplications of fractions correctly. These end probabilities should add up to 1. 3/10 plus 3/10 is 6/10 plus 3/10 are 9/10 plus 1, 10/10. 10/10, my goodness, that is equal to 1. So I add them up, 1, and I tell myself, well done. All right, now we can answer all sorts of questions with this tree. Say we wanted to know what the chances are of getting 2 red ones. 2 red ones is this one, so 3/10. If we want to write that as probability of red, red, 3 out of 10. Yes? Say we wanted to find out what the chances are of getting blue, blue. So both blue. That's this one, 1 out of 10. Those are easy. What are the chances of getting 2 different colored marbles? So different colors. Let's look up here. Which outcomes qualify as getting 2 different colors? Let's circle them. Red, red, that's not 2 different colors. Red, then blue, that's 2 different colors. Blue, then red, that's also 2 different colors. Blue, blue is not, obviously. So what do we do with these 2 probabilities? We add them. So we're going to add the probability red, blue to the probability of getting blue, red. Yes? Which equals this one, 3/10, plus that one, 3/10. 3/10 plus 3/10 is 6/10, or 3/5. Yeah? Pretty cool. Have fun with this. Yes, I'll see you later.